question in this class, one of the higher level questions, and it is to calculate the empirical formula of a compound. Now, what we're after with this laboratory data, that's what this is, like we did a lab. Okay, so that's one thing you've got to get in your mind. You know that when we do labs that the numbers are not going to be perfect because you guys are not perfect, right? So I want you to know from the beginning that when we get to the end here, and I have to explain why we have to multiply by a number, the reason is this is laboratory data. So we went into a lab and we said, okay, we've got this compound, and this compound is made up of 25.9% nitrogen and 74.1% oxygen. What is the empirical formula? What we're asking is, this is higher level, is what are the little numbers, the subscripts here, by the experimental data. So we're going to prophesy, we're going to predict, okay, what the subscripts should be in this compound. So that's what we're doing. All right, so it's really hard. This is hard stuff. So the basic steps that I'm going to teach you how to do is, number one, to assume 100 grams of the compound. Number two, convert to moles. Number three, divide by the least number of moles, LNM. And number four, with a star, multiply by a whole number. Star means if needed. If needed. All right, so let me do this. I'm going to do this one. Then the next two, you guys are going to walk me through each step. Okay? All right, so assume 100 grams. Why would I want to assume 100 grams? We went over percents yesterday. Percent means part to the whole out of how many? What? 100, okay? Part to the whole out of 100. So if I have 100 grams, and 25.9% of that 100 grams is nitrogen, what's that tell me? How much nitrogen do I have? 25.9 grams. You say, that's sort of silly. Yeah, but that's how we explain this step. We assume 100 grams, because then, here's the key statement, the percents become grams. The first step is assume 100 grams, because then the percents of that compound become grams that we can work with. Okay, so that's it. So we should change the percents to grams by assuming 100. Is that a hard step? All right, no, that's not. All right, here's a hard step. Number two, you're going to convert these to moles of the compound. Convert to moles. So how do I convert 25.9 grams to moles? I want to go 2 moles on your concept map. 2 moles. That means I multiply or divide. Divide. So I'm going to divide by the mass of whatever substance that I have. Always. I want to go 2 moles, divide. What are the different quantities we can divide by? The number of grams. We can divide by 22.4 if it's volume. We can divide by 6.022 times 10 to the 23rd if it's atoms. In this case, we have grams. We want to go 2 moles, so you always divide. So 1 mole in. Good way to check on the test is to say I want to go 2 moles. What am I going to divide? What am I dividing by the special number? All right, so this would be 14.0 grams. Okay. And then here we have 74.1 grams of oxygen. So we want 1 mole of oxygen over 16 grams. Now where did I get these numbers? I got them from the periodic table. So I'm going to take 25.9 and divide it by 14. That gives me, well,
you have to turn the calculator on first.
Turn the calculator on. It should already been on. Man, even on the computer it has power saving. 25.9 divided by 14.0, and that would be 1.85. Okay, and then we would have 74.1 divided by 16. That would give us, what was that? 4.63. Y'all need to check my numbers. You gotta make sure I don't mess up. All right, so number one, 700 grams. In other words, change percent to grams. Number two, convert to moles by dividing by the mass. Number three, divide by the least number of moles. Now, the least number of moles here is either 1.85 or 4.63. 1.85, right? So I'm going to divide both of these by 1.85. So obviously this means I'm going to have 1 in here. So 4.63 should still be up, divided by going to give me 2.5. The options. All right, so now we come, we say that I have what? N1, oh, 2.5. Guess what? I can't have a 2.5. Can't have a 2.5. So what am I going to do? Step 4. Step 4 says, multiply by whole number if needed. But if I take 2.5 and multiply it by 3, that's not going to give me a whole number. If I take 2.5 and multiply it by 4, it's not going to give me a whole number. The only thing that gives me a whole number if I take 2.5 and multiply it by 2. Does everybody understand that? Why can I not leave it as 2.5? Because chemistry rule says that you have to have whole numbers here. Okay, so 2.5, I'll multiply it by 2 here, multiply it by 2 here. When I do, it gives me N2 over 5. Step 4 is not always needed. Step 4 is only needed when you have a number that comes out with a decimal place.